Bonsuelo, athletes. Another great day. Okay, here we go. Factoring. Oh my. You know, if you have questions on this, make sure you ask me, okay? Because I'm going to do something probably goes against what you've done before. Just ask me, okay? So we're going to take this kind of slowly at first, but at the end, it's not going to be slow, okay? So if you're having any trouble at the beginning of this, you know, take your time through it. Okay. What are we doing? We're taking a polynomial and pulling it apart into things that are multiplied, not into things that are added and subtracted. You have to have factors when you're done. If you don't have factors, you haven't factored it, okay? All right. So what do you want to look for? Right, there'll be more later, but right now, this is what we're restricting ourselves to. The greatest common factor. That's the first thing you want to look for. The second thing you want to look for is either the difference of two squares or a trinomial. Now, does it have to be a difference? Yes. Does it have to be two squares? Yes. Okay. So it has to be two squares, a difference of two squares. And again, I'll show you examples of these. Trinomial, what's a tricycle? It has three wheels. What's a trinomial? It has three terms. Okay? Now, that's all I'm going to show you. Okay? A lot of people say, oh, look for this, look for this, look for this, look for this. I'm going to boil it down to two things. It's either a greatest common factor, whatever that means, or a difference of two squares or a trinomial. You factor greatest common factor one way and difference of two squares or trinomial. Either one of those you factor different than a greatest common factor, but you factor these things the same. It doesn't matter whether it's a difference of two squares or a trinomial. Those are the only two things you need to look for. So when you come and talk to me about factoring, you need to know, I'm going to say, what do you look for? And your answer has to be greatest common factor. Second thing you look for is difference of two squares or a trinomial. Okay? Now, that's what you look for. How do you factor? Okay? Greatest common factor I'll show you. But if it's a difference of two squares or a trinomial, this is what you do. You look at the first term, you look at the last term, but do not factor with the middle term. Only check with the middle term. Okay? How do you do that? We'll get there. Okay? A lot of people look at the middle term to factor, and that's where they run into trouble. Okay. So let's just take a look at examples. Okay. So all these are just going to say factor. So here, how many terms are there? Okay. Well, first of all, there are two terms. Fine. Okay. So is there a greatest common factor? Is there something that each term has? Yes, this is the first term. This is the second term. They each have a z. That's what I mean by the greatest common factor. So what you should do is write down the greatest common factor first. Not second, first. Okay? And if you're not writing it first, you're going to run into trouble. And then what do you have after you pull the z out of each term? Well, out of the first term, you have an x, and after the second term, or out of the second term, you have a 3. So it's z times x plus, times the quantity x plus 3. We factored it. We've pulled it apart into things that are multiplied. Okay, let's take a look at number 2. Right, this is also two terms. This is the first term. This is the second term. All right? So is there anything you see in the first term that you also see in the second term? Is there a greatest common factor? Yeah, there's a quantity here, k plus y. So you write that down first. I'm telling you, if you don't write the k plus y down first, you're probably going to get it wrong. Okay? So we write down the greatest common factor first. Now, in this first term, if you pull out the k plus y, what are you left with? X. And in the second term, if you pull out the k plus y, what are you left with? Plus 3. Now, I want to point out something. Number 1 and number 2 are the same problem. The only difference is number 1 has a z, and 2 has the quantity k plus y, but other than that, they're the same problem. They both have a greatest common factor. The first one has the greatest common factor of z. The second one has the greatest common factor of k plus y. By the way, what if you write the answer x plus 3 times k plus y? Is that correct? Yes, it's correct, but I pretty much guarantee you're not going to write that, okay? If you write the k plus y second, you will get it wrong. I'm not going to show you what you're going to do wrong because then you'll do it, okay? Just write the greatest common factor first, okay? I'm not saying it's not acceptable to do it the other way. I'm saying you won't do it correctly if you do it the other way. Most likely you won't do it correctly. Okay, let's take a look at this one. Again, 2 terms, let's pull out the z. Now, remember there are 2 terms. So when you pull a z out of the first term, what do you get? X. When you pull a z out of the second term, what do you get? A 1, right? You pull a z out of the second term, and you get a 1. It's not just z times x. It's z times the quantity x plus 1. Well, let's take a look at number 4. Again, there are 2 terms. So let's write down k plus y. That's common to both of them. And if you pull a k plus y out of the first term, you get x. Pull a k plus y out of the second term, you get negative 1. Again, 3 and 4 are the same problem. The only difference is 3 has a z and 4 has a k plus y. These are all examples of a greatest common factor. Okay? All right, here, number 5. Again, always ask yourself, is there a greatest common factor? Ask that first. Okay, no, there isn't. There are 3 terms here. There's nothing that each one of them has. Okay? All right, so this is then, is it a difference of 2 squares or a trinomial? Well, it's a trinomial. Okay, so how do you do it? You look at the first term, you look at the last term, and you check with the middle. Now, this is what you do. You put 2 sets of parentheses. Okay? And you're going to do this whether it's a difference of 2 squares or a trinomial. It doesn't matter. Everything else that's not greatest common factor, this is what you're going to do. You look at the first term, and you ask yourself, what times what will give you x squared? Okay? And it should be x times x, hopefully. You put that in the first position of those parentheses. Okay? Now, don't look at the negative 7x. It will mess you up. Maybe not in this problem, but eventually it will. Okay, so now let's look at the negative 18. Okay, so that's the last term. What times what will give you negative 18? Okay, now I want to point something out to you. This is just trial and error. It's tedious, but there's no shortcut to it. And someone's going to say to me, but Mr. Lieblang, if I look at the negative 7x, I can do this much faster. Yeah, and you'll get some of them wrong too, okay? So go ahead and look at the middle term. I can't stop you, but I'm just saying there's going to come a time when that's not going to help you, okay? So there are lots of things that could give you 18. There could be 1 times 18. There could be 3 times 6. There could be 9 times 2. Okay, which one do you use? Just trial and error. But this is what I'm going to do. I'm going to write down the trials, okay? Because if you don't, you're going to lose track of what you've done. So I'll just arbitrarily try the 3 and the 6. So what gives you negative 18? Let's try negative 3 and plus 6. And I'm writing them down here because I don't know that that's the answer. So now what I've got to do is check with the middle. I know x times x gives me x squared. I know negative 3 times 6 gives me negative 18. So now let's check with the middle. And how do you check with the middle? You multiply those 2, and you multiply those 2, and then you add them. Don't just combine the 6 and the negative 3. I'm telling you, it doesn't always work. Okay? So what's negative 3? And you should be able to do this in your head. What's negative 3 times x? Negative 3x. What's 6 times x? It'll be 6x. What's 6x and negative 3x? Negative 3x. sorry, positive 3x. Is that the middle term? No, it's not. Okay, so that doesn't work. Okay, so would switching the signs help here? Probably not. Sometimes it will. But switching the signs would just make, you know, if I did a positive 3 and negative 6, if you multiply it out, that's going to give you negative 3x. Okay, so that doesn't work. Okay, let's go for 9 and 2. So let's go for plus negative 2 and plus 9. Okay, now let's multiply those. And if you don't get what I'm saying when I say multiply here, you got to come and see me, okay? So we have negative 2 times x. Remember, we're going to multiply these and multiply these. And you are all now saying, gosh, that looks a lot like FOIL. Think of it that way. Go ahead. You're wrong. You'll really mess yourself up, but I can't stop you, okay? So that gives me 9x and negative 2x, okay? That gives me positive 7x. Well, notice the only thing wrong is the sign. So probably if I switch the signs, now it'll help me, okay? So I'm going to get rid of this thing. So now let's try positive 2 and negative 9. And that'll give me negative 7x, so that's what works. And so now I'll put it in here. Long, tedious, yes. Now, there's something I want to point out. Do you need to show me any work here? No. And I know right now you're saying, oh, good, because then I won't show any work. Yeah, and then don't come to me for help, okay? Because I'm telling you, if you're not writing down if you're not doing what I'm telling you to do, I can't help you. All I can do is tell you again, do what I said. And once you do what I said, then you'll start getting it. Now, if you're getting these, fine, go ahead. Do whatever you want. But if you're having trouble, you got to do it my way, okay? All right, having said that, let's go on to the next one. Okay, so there are two terms here. Is there a greatest common factor? No. Is there a difference of two squares? No, because it's not a difference of two squares. It's a sum of two squares. Is it a trinomial? No. Okay, I've checked everything I can possibly do. This can't be done. How do I know it can't be done? Because there's no greatest common factor, and there's no difference of two perfect squares or a trinomial. I'm telling you, that's all you have to ask yourself. Do you see this, and do you see this? That's why, I can't reduce it down to more than two things. Well, I guess I could do it one thing, but then there'd be no list, okay? So, you come to me and ask me, Mr. Lieblein, can you help me with factoring? I'm going to say yes. So tell me the steps to factoring. You're going to say, look for greatest common factor and difference of two squares or a trinomial. And then I say, okay, what if it's a difference of two squares or a trinomial? Then what do? Consider the first term, consider the last term, check with the middle. If you can't recite that to me, I can't help you, okay? All right, so let's take a look at this. Is there a greatest common factor here? No. Is there a difference of two squares? Yes. So what are you going to do? The exact same thing you did up here in number 5. You put two sets of parentheses. You look at the first term. What times what gives you x squared? It's x times x. What times what gives you negative 25? You can try negative 5 times 5, or you can try negative 25 times 1. Let's go negative 5 and plus 5. What is that giving you in the middle? Well, negative 5x and positive 5x is 0. And notice what's in the middle? 0. There is no middle term. So that's it. Okay? All right. Greatest common factor? No. Difference of two squares or a trinomial? Yes. So first term, last term, check with the middle. It will never vary from that. X times x gives you x squared. Now what's going to give you negative 20? I don't know. Let's try negative 10 and positive 2. Okay, that would give you 8x in the middle. And if you don't know how I'm getting 8x in the middle, you got to stop and come and see me. Okay? See, the deal is this. Let me show you something. And don't write this down, just listen. What if I asked you to take 2x, what we did in the last problem, the last video, 2x plus 7 and, 3x minus 1. What do? It's the distributive property. This times each of those. This is the reason why, by the way. So I'm going back to the multiplication and showing you why I'm telling you to do it first term, last term, and check with the middle. And then I distribute this. So what happens? When I multiply the 2x by the 3x, it gives me the first term. So notice when you take the two first terms in each factor, it gives you the first term of the resulting multiplication. Then 2x times negative 1 is negative 2x. Then I'll distribute the 7. 7 times 3x is plus 21x. And then 7 times 1 is negative 7. So notice what happens. When I multiplied the first two, I got the 6x squared. When I multiplied the last two, the 7 and the negative 1, I got negative 7. So what gives you the middle term? Right? What gives you the middle term? Notice, I'm going to get rid of multiplying the first term. I'm going to get rid of multiplying the last one. Okay? So what gives you that middle term? The 2x times negative 1 and the 7 times 3x. Okay? Not FOIL. It's a distributive property. All right? Okay. So anyway, let's go back to this problem. Okay, so that would have given me negative 8x. Okay, it's not that. Switching the signs wouldn't really help me. That would just give me positive x. So what else could give me 20? I don't know. Let's try, so we could have tried plus 10 and minus 2. Okay, that doesn't work. So what else could give me 20? I don't know, minus 5 and plus 4. But that would just give me negative x in the middle, and I don't have that. So how about if I do plus, if I switch the signs, that's not going to help me. That's only going to give me a positive 1 in the middle. So what else can give me 20? I don't know. 20 and 1. That gives me negative 19. Okay, that didn't work, and switching the signs isn't going to help. That would only give you a positive 20. So there's 10 times 2, 5 times 4, 20 times 1. Is that everything that can possibly give you 20? Yes. Did any of them work? No. By the way, let me get rid of this because, again, this doesn't belong in your notes here. I was just explaining why it worked. Okay? Have I tried everything? Yes. Did any of it work? No. Therefore, this cannot be factored. Okay? Now, let me point out something to you. If you're ever approaching a problem and saying, how do I factor this? Okay, you're already wrong. Never ask yourself, how can I factor it? They have to be specific questions. They have to be, is there a greatest common factor? And if there is, factor it out. And then the second question is there a difference of two squares or a trinomial? And if there's a difference of two squares or a trinomial, you look at the first term, last term, and then you check with the middle. I'm telling you, it just isn't going to vary from that for a very long time. So notice up here on number 6, there's no greatest common factor. There's no difference, two squares or trinomial. That's how I knew I couldn't do it. I don't have to look at it and say, gee, what can I do? It'll take you too long. Okay? Number 8, is there greatest common factor? No. Is there a difference, two squares or a trinomial? Yes. So I looked at the first term, last term, checked with the middle. Nothing worked, so you can't do it. It's not some generic ponder it and see if you can do it. Okay, now, this is what I want you to do. Stop this and do number 9. And don't continue on this video until you're done with number 9. Okay? Because I just want to show you something. All right. So I'm gonna start talking again. So I'm assuming you've paused it and done number 9. Okay. This is what most people do for number 9. Okay. So what most people do. Okay. X times x gives you x squared. And then what will give you 6 that will also give you a negative 5? Well, and don't write this down, just listen. Negative 6 and 1. A lot of people do that. And if you did that, you need to listen to what I'm saying. Because that's wrong. Why? Because negative 6 times 1 doesn't give you positive 6. See, you're looking at the middle term. You shouldn't. You should look at the last term and then see what works. So if you're doing this, and believe me, a lot of people do this, and there are other problems I can give you that are just like this, okay, where people look at the last term and the middle term together, and, you know, they're just wrong. So let's get rid of this. So what do you want to do? And, you know, it's just like the word problems. You got to follow the step, or just anything I give you. You got to follow the steps I give you. And if you're not following the steps I give you, I have no place to help you. Because if you come in for help, I'm just going to say, you know, this is what you should be doing. Okay? So anyway, is there a greatest common factor? No. Difference of two squares are trinomial? Yes, it's a trinomial. So x times x gives you x squared. What gives you positive 6? A minus 2 and a minus 3. Will that give you negative 5 in the middle? Yes. Okay? That's simple. If you did plus 2 and plus 3, then you saw it gave you a positive 5 in the middle, so you just switched the two signs. Okay, I'm not going to belabor most of these. I'm just going to go through them pretty quickly. So what you should do from this point forward is before each problem, stop the video, do it yourself, and then see how I do it, okay? But I'm not going to take a long time to do all of these. All right, because otherwise this video would be like 16 hours. Okay, so here, greatest common factor, no. So pause the video and then afterwards do this. Greatest common factor, no. Difference of two squares are a trinomial, yes. So what times what gives us x squared, x times x. What'll give us negative 72? I don't know, let's try negative 9 and positive 8. No, that only gives you negative 9 in the middle. So what else could it be? Let's see. Let's try 6 and 12. I don't know. Negative 6 and plus 12. Yeah, okay, that gives me plus 6 in the middle. I don't know I wrote these problems a long time ago, and I'm just doing them now for the first time. So that's good. And what you might have done is you might have put plus 6 and minus 12, which will give you negative 6, and you go, oh, if I just switch the signs, that'll give it to me, all right? So you have negative 6 and plus 12, okay? You know, you might get it on the first try, you might not, whatever, just do the best you can. Okay, greatest, number 11, pause it, now we'll go through it. Pause the video, do it yourself, now we'll do it. Okay, sorry about that. Okay, is there a greatest common factor here? No. Difference two squares of trinomial? Yes. Difference two squares. So we have, what'll give us 36, first of all? 6 times 6. What'll give us x to the, how do I know, by the way, that it's not 36 times 1? I don't, you know, although it's a difference of two squares. Notice 36 is a square, x to the 4th is a square, 49 is a square. Okay, so that's how I kind of knew it was 36. But, okay, what times itself, because this is a difference of two squares, will give you x to the 4th. X squared times x squared. What times what will give you 49? Negative 7 and plus 7. Okay, will that give you nothing in the middle? Yes, if you multiply, you know, you get negative 42 and positive 42. That gives you nothing. That gives you 0 or nothing in the middle. Okay, let's take a look at this one. Is there a greatest common factor? Yes, there is. And if you don't pull it out, if you don't look for that first, this problem is just about impossible. Okay, so let's take out x, and we get x squared. By the way, if you're not trying these on your own, you're not getting out of this video what you should be getting out of this video. Okay? And now, do I have another greatest common factor? No. Do I have a difference two squares or a trinomial? Yes, I have a trinomial. Okay, so what times what gives us x squared, x times x? What gives us negative 24? I don't know, let's go for negative 6 and plus 4. Okay, that'll give me negative 2. Switching the signs isn't going to help. Let's go for negative 12 and plus 2. That gives me a negative 10. So if I switch the signs, it'll be okay. So that's plus 12 and minus 2. Okay. All right, here, number 13. Again, pause the video. Now let's go through it together. Okay, is there a greatest common factor? Yes. Pull out an x squared, because there's 3 terms here. Again, don't look for a difference two squares or a trinomial until you've looked for the greatest common factor. So that'll give us x squared minus x plus 1. Okay, is there a difference two squares or trinomial? Yes, there's a trinomial. So we have x times x will give us x squared. What will give us plus 1? Plus 1 and plus 1, but that gives you 2x in the middle. Negative 1 and negative 1 is going to give you negative 2x. Nothing else gives you 1, so this doesn't factor any further. Again, it's not if you're asking how do I do this, you're wrong. It's got to be specific questions. Okay, greatest common factor? No, there are 3 terms here. Nothing in each one. Difference two squares are trinomial. Yep. Trinomial, what do? Same thing. I mean, it's like a broken record. What times what gives you 4v squared? Let's go for 4, sorry, not 4. I mean, it could be 4, but I'm probably going to go for 2. Okay, so let's go for 2v and 2v. What times what will give you 40? Don't look at the 20. Don't worry about the 28vy. What will give you the 49y squared? I don't know, probably plus 7y and plus 7y. Does that give you 28vy in the middle? Yes, because it's 14vy and 14vy. All right? All right, let's take a look at the next one. Okay, greatest common factor. No. Difference two squares are trinomial. Yes. Okay, what gives us 2x squared? 2x and x. I'm telling you, it doesn't matter how bizarre the problem gets. You just do exactly what I've said to do. Okay, now let's try 21. Let's go for, I don't know, let's go for plus 7. And plus 3. Okay, what would that give us in the middle? That would give us a 7x and a 6x is not 21. Okay, would switching them help? Yeah. Why? Because, see, I have this 2x on one of them and the x on the other. So it hasn't happened yet. The only thing we've done up until this point is switch signs, okay? But you know what? Like up here on, let's take number 10. When I tried negative 9 and 8, I could also try 8 and 9 in a different order. It didn't make any difference in this problem, but in this problem it does. So let's go for plus 3 and plus 7. And what will that give us in the middle? Well, that will be plus 14 and plus 3x, which gives us plus 17x. And if you're not writing down these trials, you know, this is what I mean by the trials. These lines here, you're not going to know what you've tried and what you haven't tried. So you're not going to know whether you've, switched trials or not. See where it was 7 and 3 on the first one and 3 and 7 on the second one? If you're not writing them down, you're not going to know if you've done it or not. So then we have plus 3 and plus 7. See, as long as it works for the first term and the last term, then all you have to worry about is the middle term. Okay? All right, let's take a look at this one. So, greatest common factor? No, because there are 3 terms. They don't all have the same thing. Is there a trinomial or a difference two squares? Yes, it's a trinomial. So what do? Same thing. It will never vary. Not yet. Someday it will, but not today. Okay? So what times what gives us x to the 4th? X squared times x squared. What times what will give us a negative 42? I don't know. Let's try negative 21 and plus 2. Okay, that's not going to give me an x squared in the middle. I can try switching the signs. That's only going to, that's going to give me, right now it would give me negative 19. If I switch the signs, I get plus 19, so that's not going to help me. If I switch the position of the 2 and the 21, you'll find out that's not going to help you. Okay, so what else can give you 42? Let's go for plus 6 and minus 7. Okay, that would give me negative 7x squared and 6x squared. That would give me a negative x squared. Well, if I switch the signs, that's going to give me then a positive x squared. So I want minus 6 and minus 7. Okay, now you should always look to see if you can factor it again. So here, let's look at each of these factors. We'll look at this one first, and then we'll look at the other one next. And the thing I've just underlined, we'll look at the x squared minus 6 first, and then we'll look at the x squared minus 7 second. And the thing I've underlined, is there a greatest common factor? No. Difference two squares are trinomial? No. That's how you know you're done. And the second one, the x squared minus 7, is there a greatest common factor? No. Difference of two squares or trinomial? No. That's how you know you're done. Okay? All right, number 17. Greatest common factor. Yes, there's a 5 in every term. So you take out x squared minus 5x minus 6. Okay? And let's take a look at this. So again, I'm just going to show you what people do. But again, you should be trying this on your own. People go, oh, this is the one he showed us before. So it's x minus 2 and x minus 3. And that's wrong because negative 2 and negative 3 don't give you negative 6. You've got to look at each problem unto itself. Some problems can look very similar, but they're not the same. So what times what will give us negative 6? Well, let's try negative 2 and positive 3. That'll give us negative 6, but that gives us an x in the middle, and that's not going to help. You can try switching the signs. That's not going to help. So let's go for positive 6 and negative 1. That would give me a 5x in the middle. So I'll just switch the signs. Okay. Okay, let's take a look at this one. Is there a greatest common factor? Yes, there's an x plus 7. Now, pull out an x plus 7, and what are you left with? K plus 1. And if you don't understand how I got that, you got to go all the way back and just redo problem number 4. It's the exact same as problem number 4, just different letters. Okay, so go back and take a look at problem number 4. Okay, on this one, how many terms are there here? There are 2 terms. Okay, is there greatest common factor? No. Difference of 2 squares or trinomial? Yes. So what do? Look at the first term, look at the last term, check with the middle. I'm telling you, it'll never vary. But what you have to realize is this whole thing is the first term, and this whole thing is the last term. So we're going to leave ourselves a little more room here. Well, what times what gives you the 3x plus 15 squared? Well, I hope it's pretty obvious. It's 3x plus 15 times 3x plus 15. It's something times itself. This is a difference of 2 squares. And now, what will give you a negative in the middle? One of them negative and one of them positive. And what will give you x minus, by the middle, by the way, that's not a middle term. That's actually the beginning of the last term, okay? So I'm not saying that negative is the middle term. It's not. It's the beginning of the last term. And what gives you x minus 42, quantity squared? Well, hopefully it's pretty obvious. It's x minus 42 times x minus 42. Okay? That's it. First, well, I'm not done. But now you should simplify what's in this set of parentheses. And if you simplify that, you get 3x minus x is 2x. And 15 minus negative 42 is positive 57. And then you should simplify what's in this set of parentheses. So we have 3x plus x is 4x. And then 15 plus a negative 42, okay? 15 plus a negative 42, and my brain just froze. But it's, negative 32, negative, I believe, 27. This, I make mistakes. It might be, I'm pretty sure that's right. Okay? Now, let's take a look at these. Is there there are 2 factors. Let's look at the first factor. Is there greatest common factor there? No. And it's not a difference of 2 squares or a trinomial. And the second one, is there greatest common factor there? No. And there's not a difference of 2 squares or a trinomial. So we're done. First term, last term, check with the middle. It's just not going to vary from that. Okay, it's trinomial. Again, you should be doing it on your own first. So we got x times x gives us x squared. What's going to give us negative 24? Let's go for negative 6 and plus 4. Okay, that's going to give you negative 2x in the middle. Switching the signs isn't going to help. Okay, let's go for negative 12 and plus 2. Okay, that's not going to give me 5x. Let's go for negative 24 and plus 1. Okay, that's not going to help. Well, is there anything else? Well, you know what you can do? If you want to see if there's anything else, pull the 24 over. And I showed you how to do this with radicals, okay? Factoring a number. 2. So If you don't remember how to do this, you got to go back and look at the radical video. Okay, so what we're going to do is try different combinations of 2, 2, 2, and 3. So I've already tried 4 times 6. I've already tried, oh, I haven't tried 8 times 3 yet. Okay, so let's go for -8 and +3. So I'm just trying different combinations of 2, 2, 2, and 3. So I tried 2 times 12, I had that. I had the 4 times 6, I had that. But then all of a sudden I realized I hadn't done 8 times 3, okay? And that'll give me -5x in the middle. Okay, good. So all I have to do is switch the signs. So it doesn't have to be some like arbitrary guessing. If you know, go ahead and start off with just trying things. But then, I can't believe I hadn't tried 8 times 3. Anyway, but if you need to, go ahead and factor the number, you know, that last 24, and then just try different combinations of the numbers. Okay, let's take a look at this. Greatest common factor, no. There are 3 terms here. Greatest common factor, no. Okay. Difference of 2 squares or a trinomial. Yes, it's a trinomial. So what do? First term, last term, check with the middle. It'll never vary from that. So let's look at the first. Don't worry about that middle term. What times what gives you x plus 17 quantity squared? X plus 17 times x plus 17. Okay, what gives you -24? Well, you know what? I'm just going to kind of try, for reasons I'll get to in a second, +8 and -3. What does that give you in the middle? Well, remember, we're going to multiply those and those to figure out the middle. So that gives me 8 times the quantity x plus 17 and -3 times the quantity x plus 17. Does that give me 5 times the quantity x plus 17 in the middle? Yeah, it does. Okay? And you might have a little trouble doing this. Why might you have a little trouble doing this? Because you use a calculator a lot, probably. You need to be able to make simple, because these are simple calculations, quite frankly. You need to know how to add, subtract, and multiply numbers. That's really all there is to it. Okay, so let's put +18. Let me get rid of these arrows. Okay, let's put, not 18, +8 and -3. And you want me to point out something to you? Look at problem 20 and problem 21. They're the same problem. They're the same problem. Except in 20, you just have an x. In 21, you have an x plus 17. Other than that, look at it. They're the same thing. Something squared plus 5 times that thing minus 24. They factor the exact same way. Now, the only difference, though, is we do need to simplify this, you know, what's in the parentheses here. So we're going to take this, and then we're going to take this, and we're going to simplify it. So this one becomes x plus 25, and this one becomes x plus 14. Okay? All right. I don't know how many more we have to go here. Let's see. Oh, this is the last one. Okay. I think I left a lot of paper on this one because this one's going to take a while. All right. Let's try it. Greatest common factor? No. Difference of 2 squares of a trinomial? No. So I apologize. Difference of 2 squares of a trinomial? Yes, you have a trinomial. So what do? First term, last term, check with the middle. Okay. Now, what gives you 10x squared? 5x and 2x. Now, do I know it's 5x and 2x? No, I don't. It may be 10x and x. How do you know? Trial and error. You got to write down all your trials, and as soon as you've gone through all the possibilities with 5x and 2x, and they don't work, then you start over again with 10x and x. Okay, so let's go for it. 12. And I'm going to do it off to the side here. So we have 2, 2, and 3. Okay, so we're going to try all the different combinations, and hopefully one of them works before I have to go through all of them. Okay, let's go for 4 and 3. Okay, so that gives us 15 and 8, and oh, they say there is no God. Oh my, are we lucky. It worked right away. We are lucky. But let me just show you something real quickly. Let me go back then, okay? Let's say we didn't luck into it. And gosh, if we do, I think it's the greatest thing. Let's say you had tried 12 and 1. Okay, that would not give you 23x in the middle. So you'd have to switch and try 1 and 12. That also would not give you 23x in the middle. Now, you might try, now I can't remember what I said worked. And then you'd probably try maybe 6 and 2. Okay, so that would give you 12 and 10. That wouldn't work. 2. I'm just trying to give you an idea of the way you should go about doing this. Okay, so you switch them. That would give you 30 and 4. And if you can't do this quickly in your head, I don't know. You just got to practice. And you just got to come in. Because, again, all you're doing is you're taking those two and adding it to those two multiplied, every single one. And if you haven't been doing it that way on the easier problems, so you need to get in the habit on the easier problems. So when you get to the harder ones like this, you know what to do. Okay, so that doesn't work. So I can't remember what I tried. I think it might have been 4 and 3. Okay, that would give you 20 and 6. So that'd be 26. So that doesn't work. So we try switching the 4 and the 3. And that's going to give us 15 and 8. Yeah, and I lucked into it before, so that's going to be 4 and 3. And if you went through all of those and those didn't work, then let me show you what you do. Although we're done with this problem. You would then try, okay, what else could give me 10x, 10x, and x? And then you know what? If you've written down all of these trials here, you don't have to go back and try and think of all the different combinations because you've got them here. So you try 12 and 1, then you try 1. You just start copying and just see what works. It's just tedious trial and error. I mean, there's just no two ways around it. But you know what? Let me tell you something. If you do it the way I'm telling you to do it now, not in like a week, I can't help you. You're stuck, okay? But if you do it the way I'm telling you to do it now, eventually you actually get really quick at this. It's really not that hard, okay? But you have to do it now with the easier problems the way I'm telling you to do it. If you didn't listen very carefully and really pay close attention on these first problems, okay, you just think you're going to do it. Well, when you get down to this thing, like number 19, okay, number 21, you're not going to just do it. You have to be in a habit of knowing what to do when you don't know what to do. It's the same with like word problems. You know, people think they just know what to do, and sometimes they do and sometimes they don't. You know, if you know what to do, just do it. Same thing here. If you know what to do, do it. Please, do it the quickest way you can. But I'm trying to show you what to do when you don't know what to do. That's what I'm trying to show you, is what to do when you don't know what to do, okay? And there's no shortcuts to it. There's just doing the work and building up a habit. And once you have that habit, okay, then actually it becomes pretty easy. All right? So, again, come and see me for help. But the first thing I'm going to ask you is, how do you do this? And if you don't have this idea, at least memorized, I don't really have any place to help you. I don't know what to tell you, Like this video, I don't know how long it is, but it's been going on for a while. And I can't possibly do this with 160 individuals. So, really, if you come in prepared, it doesn't take that long. Okay? And if you come in frequently, it doesn't really take that long. But if you're saving it up until like right before the test, when everyone and their mother comes in to get help, there's just not going to be enough time. You got to do it every day. You got to be prepared every day. All right? Have a good day.